How's it going, everybody? One of the things that I wanted to cover as we transition, or as I transition from workbook development for CCNP service provider with Rikers Island training over to the video courses that I'm going to begin here very soon. I wanted to give everybody a kind of a behind the scenes look at how it is that I build the infrastructure to build the labs. And what I mean by that is if you are if you're following along with the labs, I know I've picked up quite a few customers through workbooks and stuff like that over the past month or so. One of the questions I get a lot is how do you leverage ESXi and vSphere to demonstrate the technologies that you demonstrate in the labs and the videos? Simple answer to that question is it's magic. I will actually go through and break down some of the things that I do to build it out, because just like I did for when I was studying for my CCIE, I walked you guys through how to deploy a router and stuff like that, and there was really nothing magical to it. It was just a matter of mapping a bunch of routers to a common vSwitch and then using .1q trunking to basically create networks. That same logic carries over to what I'm doing now, and I've created probably a dozen topologies to highlight the CCNP service provider technologies that I have just finished up the workbook development with. So as of right now, the end of June 2018, the workbooks for CCNP service provider are complete. I will begin transitioning over to video production here very soon. I'm not sure if I'll begin it tonight, but very soon. And what you see on my screen is my ESXi server, where all the routers that I have used in the workbooks are currently running. So it's an IBM server. It's a 3650 M2. Hyperthreading is enabled. VTX is enabled. So basically hardware-assisted virtualization is enabled and ready to go. What I'm going to do in this video is I'm going to walk you guys through how it is that I set up the behind the scenes stuff. So how do I connect the routers to each other? How do I allow the communication between two routers to simulate layer 2 VPNs and things like that? That seems to be the biggest sticking point. There are people out there that use other virtualization techniques. They might run ESXi as the hypervisor, but they use something like Eve, or they might use GNS3, or whatever other platforms are out there that I don't use. You might even use Viral. I haven't used Viral in a while, but I still have it available to me if I wanted to use it. And what I'll be doing is I'll be walking you guys through exactly how I go about setting this stuff up. So from the routing perspective, it's really no different than the CCIE V5 lab setup video that I did probably 3 years ago with somewhere in the neighborhood of like 30,000 views. Service provider is a little bit different because there's other technologies that are on the service provider blueprints for CCNP and CCIE that are going to be tested on at both the CCNP and CCIE levels that you need to be able to demonstrate proficiency in. Now, I just finished up a pretty in-depth MPLS setup. I mean, I went through and I demonstrated in a bunch of labs how to do a bunch of things. If you would like to know more about what I've already done, check out Rikers Island Training, go to the products, go down to CCNP, and then pan across till you find service provider workbooks. All 4 service provider workbooks are complete as of right now. The initial configs will go up for them here very soon. I'll actually probably tweet out and put an update on LinkedIn for everybody. But what I wanted to cover here in this video specifically is how it is that I go about getting all of the configuration on the host ready so that when I bring up the routers and stuff like that, things work. So let me explain exactly how I go about doing this. So I'm going to take, for instance, this topology right here. So this right here is the topology that I used to demonstrate intra and inter area AS layer 2 and layer 3 VPNs. Now I didn't go into any real detail on inter autonomous system layer 2 VPN. I did some basic point to point and VPLS stuff, but what I wanted to highlight topology wise to make sure that everybody's on the same page and everybody can follow along is exactly how I went about doing this, because this is the sticking point that I get a lot of questions on that people have a hard time understanding. So here is me being extremely transparent in trying to help you guys understand what it is that how I do things. So for instance, anytime you see in any one of my topologies, you see a interface like this or an interface like this, that is a routed connection, because there's a VLAN ID here, there's some encapsulation set up. So basically all of these interfaces that you see are these links with a number associated to them. That's a VLAN ID. So when I go in and I create an interface on XR5 and R5, that's a .1Q sub-interface. So that's how the routing component comes into play. That's why I'll have several sub-interfaces configured under a single interface. They'll all be router on a stick. So if you were to imagine a bunch of routers here, take R5, XR5, and we'll take R7 for instance. Their gig 1 interface, their gig 0000 interface, and the gig 1 interface all connect to a common vSwitch. This is no different than you taking 2 or 3 physical routers. You take three physical routers, you plug them into the same switch, right? All these links that the routers are connected to on these switch ports, all these switch ports right here are configured as trunk ports, and then you enable whatever VLANs you want. Let's say this is VLAN 12 and this is VLAN 24 or 23. So you can create VLAN 12 and you create VLAN 23, and then you would trunk, you would allow the trunk links to have all the VLANs. So 12 and 23 are allowed here, here, and here. So when I go to create a .1Q subinterface over on this side right here, and over here right here, and configure that to be in VLAN 12, then I type in gig 1.12 encapsulation.1q 12 10.1.12.1 for router 1 /24, and I go over to router 2 and I do the same thing, gig 1.12 encapsulation.1q 12 IP address 10.1.12.2 /24 and hit the enter key, and then I go send a ping from R2 to R1. After the ARP resolution occurs, you end up getting a response because the MAC address is able to propagate through and figure it out. This right here is exactly what I'm doing over here, but all of the routers and all of the switching is done on the ESXi server. That's the easy part, because it's something that you can easily correlate, layer 2 VLANs and trunking and .1Q encapsulation. For anybody that's above, Network Plus is something that most people are familiar with. You don't even have to have a CCNA to understand these concepts. I mean, I teach that at CCNP. There's people I know that don't even have a CCNP that understand basic .1Q trunking. Now, it's the layer 2 VPN stuff behind the scenes that most people don't get, or they're like, how do you accomplish that? Well, for one, on the routers that I'm using in my lab, the iOS routers, so CSR 1000V, which is actually iOS, if I could write, iOS XE, right? It's not actually iOS, which it actually is a misnomer. It actually is iOS, but how it's compiled on the router itself is different, right? So maybe you don't know this, so I won't say right. I can't assume you know what I'm talking about. So just a brief history lesson on the evolution of the Internet Working Operating System, or iOS. It started off as just regular iOS, a monolithic operating system that took full control of the kernel. So when I say the kernel, I'm referring to the CPU of the router. So for those of you that have come from the Dynamips days in GNS3 like I do, 4, 5, 6 years, 7 years ago, that's how I got started. I dealt with an iOS router, it ran iOS. So the CPU, if any one particular service, OSPF, RIP, NAT, DNS, DHCP, pick a service that you could enable, pick a feature you could turn on. If any one of those features took a crap on the box, it would reboot the box. I mean, I can't tell you how many times that I've ran into a NAT bug doing some sort of wacky NAT configuration and it doesn't work, and I come to find out, oh, that's a NAT bug. You can't turn that feature on with this one. It won't work if you got zone-based firewall turned on with the self-zone. Who knew? A long time ago, 12.2 code, if I'm not mistaken. That thing's been long since fixed. What ESXi did, or what Cisco did with XE, is they put it into a distributed architecture. So simply meaning they took iOS, and it's no longer encompassing the entire hardware embodiment of the architecture. Now they run it as a daemon. So for those of you that come from the Linux background, it's no different than any other service on the router. So iOS D, the little d, that's the daemon. So when you're running a router, it looks like iOS from the command line perspective. And when you're managing it from Prime or SolarWinds or whatever, those boxes are none the wiser. It looks like an iOS box. But iOS is running as a daemon or as a service. So what will end up happening is, as I'm going along doing whatever it is that I'm doing on the box, I'm affecting everything, but because of the fact that they've distributed the architecture across multiple components on the hardware, and depending on who you talk to and depending on what platform you're referring to, it kind of varies from engineer to engineer. I mean, I've talked to a bunch of, I've been to Cisco Live twice, and I've talked to a bunch of engineers on the ASR and the ISR platforms, and I get kind of the same story, but they vary so and so. But at the end of the day, XE is a daemon, so it's iOS D. What'll end up happening here is the box runs the way that it runs because the architecture changed. So if a feature takes a dump, then it's not supposed to take down the whole box. Now, iOS XE or CSR 1000V does support, and this is the reason I went through that little monologue, does support layer 2 VPN in the data plane to a point. So for those of you that are looking to dive headlong into layer 2 VPN like I did probably a year and a half ago, and it's taken me a long time to really wrap my head around it because it wasn't something that I was very familiar with when I first started with it. I'm getting more and more comfortable with it, and the more and more I play with it. XE will support point-to-point pseudo wires. It'll support VPLS, HVPLS, and it will support PBB EVPN as a route reflector. Now, it does support the data plane, and I haven't taken it much further beyond that. So there are advanced capabilities that it does support. iOS XE, so the CSR 1000V does support both BGP and LDP signaling for VPLS for auto discovery. However, another evolution, a different software track, is iOS XR. It's a completely different platform. That is also on the blueprint. It also supports layer 2 VPN, but iOS XR V does not support layer 2 VPN at all in the control plane, or in the data plane. It does support layer 2 VPN in the control plane. Now, in the labs that I built for the workbooks, I didn't incorporate much XR in there, simply for the fact that it doesn't support it in the data plane, and just showing you some control plane output really I didn't see the value. I will be taking and showing you more in the videos on XR on how layer 2 VPN in the control plane works, and actually setting up iOS XR to support layer 2 VPN and things like that, so that you're familiar with it. It supports them all. You can run VPLS, you can run hierarchical VPLS. There's some limitations where XR can't be used as a NPE, so basically the core of the network-facing provider edge in a hierarchical VPLS design. If you have no idea what I'm talking about, stick around. There will be, I'll be covering some content on Layer 2 VPN here in the near future. I don't know how much I'm going to publicly release to YouTube versus how much I'm going to keep on my site. Stay tuned for that. But ESXi does support all of them. I haven't covered PBB for CCNP because it's not covered. It's describe it. So it's very similar to Layer 2 VPN with MPLS as the encapsulation, except for there's a PBB header and some advanced capabilities for multi-homing. So the reason why you're really here is, how do I make all this stuff work? But I felt like I had to cover some of the back end stuff so that at least you know what's going on. Now, the last little bit that I'll cover is I do have ESXi 9K rolled out in this. It's not in the topology, but it's running in the server. As a matter of fact, if I pull this guy back up, I have XRV 9K running. I have one box running. It does run. Layer 2 VPN is very, very finicky. As a matter of fact, when I was at Cisco Live in Orlando a couple weeks ago, I explicitly asked the question, and I don't know. I watched the video of the session that I sat in on Monday morning at 8 a.m. and I asked the question, but you can't really hear me, and the guy repeated it, but he didn't really give me a solid answer. So the simple answer is, until you get to ESXi 6.4 on the 9K version of the ESXi V platform, it only supports Layer 2 VPN point-to-point VPS, Virtual Private Wire Service. That is the only one it supports currently. That's the only thing that if you go out and you look at the release notes, that is what Cisco has publicly stated. That version of code supports Layer 2 VPN in the data plane. That's what they're stating. I have not been able to get a download of it to test it out. So because of that, I can't verify that. But I can verify that when I tried to set up XRV 9K with the point-to-point pseudo-wire between XRV and, it's not on this topology here, and R17 through the targeted LDP session came up, but there was a bunch of traceback errors. Basically, it's almost seemed like a memory issue kicked off, and it would not work. So, Layer 2 VPN on ESXi 9Ks in 6.0 code apparently does not work. So, my assumption is they're not going to test you other than maybe route reflector, because you can use a route reflector, XR as a route reflector for Layer 2 VPN, but if I'm getting that problem with just a regular X connect, which is the simplest of the Layer 2 VPNs, it's point-to-point pseudo wire and whatnot, it wouldn't work. So I'm going to continue testing it out a little bit because I was kind of in a crunch time to get something working. So I wanted to see if it would work. It didn't. So XR on 6.0 code, as a matter of fact, let me go ahead and just pull it up real quick here for you. It wouldn't work. So if I come in here and I connect the tabs, I'll go ahead and log into it real quick. So if I do show ver, this is XRV 9K and 6.0.2, and if I do a show run L2 VPN, oh, I blew it away. That's right. So show IP interface brief. I do have a connection, and as a matter of fact, I blew away the connection because I restarted the configuration. These routers here are actually set up for a different topology for carrier supporting carrier. I'm going to be integrating the 9K into the CCIE content that I'll be beginning pretty soon here. I'm going to start building the workbooks, doing the videos. None of that will get released until until after I pass the lab. Then I'll start releasing it. But I'm going to start digging into that because there's Layer 2 inter-AS Layer 2 VPN, and multicast VPN, and then a couple of services that I need to cover, and I think I'm pretty much ready. It's just a matter of going back through and testing other advanced features. So enough babbling from me. So on my topology, how would you know where a layer 2 connection comes into play? So the answer to that question is anything you see like this. You see a line drawn between two routers, but there's no VLAN ID. That means it's just it's a physical wire. In this case here, it's actually two interfaces, so gig 2 here and gig 2 here on the routers. And what I've done is I've created additional vSwitches. So I create a vSwitch, I give it a name like L2VPN underscore R17 underscore R8. So what I'll do is I'll go onto the vSwitch and I'll say, you know what, basically make this a trunk link. So allow the switch to take in as many VLANs as it can. So 4095. And then what I do is for the promiscuous mode, I set it to accept. And then by doing that on R17 and R18 on the connections here, I can specify on this side a service instance or an XConnect that I can receive traffic from. Same thing over on this side. I simply configure the interface with the .1q tag on this side because it's the gig 2 interface on R17 is the provider edge inbound interface for the circuit. So if I was to bring up my server here and go to configuration and go to networking, come all the way down to the bottom here, we'll grab, for instance, it should be right here, R17, R18. And as you can see, I've got R17 and R18 in this connection. You can see right here, as a matter of fact, I will grab my magnifying glass just so you guys can see this a little easier. You can see right here that I have the 3 virtual machines. The VLAN ID is all, which means it doesn't matter what R17 specifies as the inbound encapsulation or VLAN ID, and it doesn't matter what R18 states. It's going to accept whatever R18 sends. So allow all the VLANs, and then on the properties tab, if we come in here, if we look right here where it says promiscuous mode under security, it's set to accept. Now I created additional vSwitches in an effect to basically create discontiguous networks. So in a real world situation, if you were to order layer 2 VPN service from a service provider, they're going to deliver a circuit to your building. So that's going to be what they refer to as the attachment circuit. The attachment circuit plugs into either hardware that they will provide to you, like an ASR 902 or something like that, or like an ME3800 switch, something along those lines. They'll deploy this box to your location. They'll bring in a fiber circuit and terminate it, and then they'll do some configuration on the switch, and then they'll say, okay, you can plug your equipment into any one of the ports here. You plug your fiber or Ethernet cable into the switch, and voila, things just magically start to work. Now, the device that's terminating the fiber circuit that's coming in from the provider and the fiber that's leaving the provider edge router going to the customer, this is what the switch is emulating. Okay, so I create this vSwitch, and if I go in here and actually let me go ahead and if I go to R17 and I click on edit settings on gig 2, here I've got L2 VPN. Go ahead and pull that up again real quick. Oh, no, not that. This. It says L2 VPN R17 underscore R18. I've applied that label, so that vSwitch to this interface, right? It's connected and power on, everything's good to go. I do the same thing on R18. Edit settings. On gig 2, we have the same thing. Connected to power on, everything's groovy, right? Everything's good to go. Now because of that, that allows me to do a couple of things. That allows me to take a situation like this. Now currently these routers have been reconfigured. If I do a show run interface gig 2, the service instances are still here. If I go to 18, show run interface gig 2, gig 2, or show IP interface brief. I have several individual .1q sub interfaces that are configured. And the reason for this was to test out different layer 2 VPN capabilities. You know, with the control word, without the control word, with sequencing, without sequencing. And a lot of it was just looking at the outputs. You know, if I created VPLS with a bunch of manually configured pseudo wires and didn't use BGP auto discovery with LDP signaling, then how would that look from the customer's perspective? Well, I found out for just about, well, what do I have? 10 or 11? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 individual sub-interfaces on this box. Router 18 didn't see anybody, and for a while there I had a bunch of EIGRP adjacencies. If I do a show run section EIGRP, show IP EIGRP neighbor, I've got nothing up because right now they're all broken. That's because of the fact that I'm actually doing carrier supporting carrier on these boxes. So if I go in here and I do a show IP route BGP, I've got carrier supporting carrier running in the background. As a matter of fact, go ahead and pull up this topology here. We see that R2 is over here on the far left, R4s are on the far right, and if I do a trace route to 192.0.2.4 sourcing from loopback 0 numerically, I have a 3-label stack, and I've got carrier supporting carrier running in the core, which is what I would want to have. But yes, you can run layer 2 VPN in inter-autonomous system, option A, B, and C. It's supported for carrier supporting carrier. It's also supported for unified MPLS. It's also supported for intra-AS. On my workbook, I only did 2 basic inter-AS labs because they were relatively simple. I have not gone into the inter-AS side yet, that deep. That's an area that I haven't gone into yet. I will be here very, very soon. But that's basically what I do. I create a vSwitch. So if I wanted to create another one, I'd simply click on Add Networking. I would be a virtual machine. So a virtual machine basically is just a VLAN itself. The VM kernel, it would be effectively the Switch Virtual Interface, or SVI. I click Next, and then I say I don't want to apply it to any network adapter because I wanted this to be a local switch only. So I'm creating a new vSphere vSwitch. Click Next on that guy, and then I come in here and I give it a name. We'll type in L2 VPN underscore test. That'd be the name. I click on what VLAN ID I want to give it. Here I would say all 4095. I click Next, and then I click on Finish. Now that creates a new vSwitch. I scroll all the way down to the bottom, and there's the new vSwitch. I go to Properties, and what I have to do at the vSwitch level itself, not the individual port groups that are created by it. So when you create a new vSwitch, it's like having a new physical switch, new Cisco switch, Juniper switch, whatever the case might be, and they're all physically disparate from each other, there's no way to connect them inside of ESXi, unless you go out of ESXi to the physical network and then back down again. That's the only way that's going to work. So here the promiscuous mode is set to reject at the switch level and at the port group level. So if I say Edit and then go to Security and then say Accept, once I've done that and click on Close, any ports that I put into that particular port group, so if I go to R17 for instance and I click on Edit Settings and I go to VM Network and I click this and I scroll down to Layer 2 VPN Test, there it is. I click OK, and now that network adapter is inside of that vSwitch. If I connected another router's interface to that same label, they would join the same VLAN or the same trunk, but at the virtual switch layer. So that's basically how this works. That's all I'm doing. I want to keep this video at about the half-hour mark. If you have any questions regarding this, please feel free to drop a line in the comments below. For those of you that have been a long-time subscriber, or if you're brand new to it, I do appreciate it. You guys are awesome. Thank you so much for the support. I would really appreciate it if you would bang that subscriber button, click the notifications tab, and give me a like so I know that you got something out of the video. And until next time, guys, take it easy.